All right, section 4C, properties of logarithms. We're going to learn a couple of logarithm properties in this section that are going to help us in the next section to be able to solve some equations with logarithms. All right, before we do that, I want us to remember evaluating logarithms, and this will also help us to verify these new properties. So I want us to evaluate the log base 2 of a few different numbers. We're going to do the log base 2 of 2, log base 2 of 8, and the log base 2 of 16. Okay, so if you feel pretty confident that you can do that on your own, go ahead and pause the video just to kind of have a little review here. And when we do this, we're going to do our logarithm DNA calculation. We're going to convert from logarithmic form to exponential form. So I'm going to go ahead and do that for all three of them. I'm going to do my DNA, DNA, DNA. All right, we'll figure out the exponents on the right. 2 to the first is equal to 2, so that means this logarithm is equal to 1. 2 cubed is equal to 8, and 2 to the fourth is equal to 16. All right, so I'm going to use these three logarithms. Have those copied down on your paper so you can reference them for our next few properties. So the first property of logarithms that we get, this property tells us that if we have a logarithm of any base, doesn't matter what base, we can distribute that logarithm over multiplication. And when you distribute a logarithm over multiplication, you end up with addition between the two logs. Right? So I'm going to verify this property. It's kind of a strange looking property by thinking of 16 as being 8 times 2. All right, so this property says that if I take the log base 2 of 16, and I'm going to write 16 as 8 times 2, log base 2 of 16, this property says I can distribute my log base 2 to 8, and I can distribute it to 2, and this should still work. All right, so just remember the values that we calculated. We calculated log base 2 of 16 was equal to 4. Log base 2 of 8, we had 3. And log base 2 of 2 is equal to 1. And this property says that we should be able to add on the right and get the same thing we do on the left. And we do. All right. And this property of logarithms is kind of related to our property that would tell us if we had multiplication that we would add those exponents. Okay, so we add those exponents to get the one on the left. And since logarithms are exponents, that is why this works out. Okay, so we'll kind of take that property and put it in our pocket. Our second property is this one, that we can distribute logarithms over division, but when we do, we need subtraction in the middle. Okay, so again, I'm going to think about 16 as being, let's try that again. I'm going to think of 8 as being 16 divided by 2. So this property says that the log base 2 of 8 is equal to the log base 2 of 16. Again, I'm just distributing my logarithm over division. Log base 2 at the top minus log base 2 of the bottom. All right, so again, just check. Log base 2 of 8 we calculated to be 3. Log base 2 of 16 we calculated to be 4. And log base 2 of 2 we calculated to be 1. And again, we see if we subtract on the right, we get the right answer on the left. Okay, so all I'm doing here is verifying that this property makes sense to us because it looks like a big alphabet soup. All right, then our third property says that if you have an exponent inside a logarithm, that exponent can come down out front as a multiplier. Okay, so this time I'm going to think of 8 as being 2 cubed. I'm just going to write it with an exponent. So this tells us that the log base 2 of 8, it's hard to say 8 and write a 3. log base 2 of 8. This tells me that I can bring that 3 down out front, and it should be the same thing. 3 times the log base 2 of 2. Okay, again, on the left, we calculated the log base 2 of 8 to be 3. And on the right, I've got 3 times the log base 2 of 2 we calculated to be 1. All right, and we get 3 times 1 equals 3, and that works. All right, so that verifies to us that these 3 properties are true. All right, so in the next video, we're going to use these 3 properties to actually simplify some or expand some expressions.